So let me start the recording part.
This conference will now be recorded.
Okay, there we go. Any questions before we get started? So my plan today was to walk you through a number of tools that we typically use when we're doing analyses like this, GIS analyses. And some of these tools are associated with the data cube. I'm also going to show you how I use Google Earth from time to time to also supplement some of the things that we do. So everybody good? Ready to go?
Yeah, we are ready.
Okay. So I'm going to start here today by first, the PDF document that I sent to you gives a summary of what I'd like to walk through today. The focus of this training would be how can you use the data cube to investigate the mining activity throughout Ghana. So I've had some interactions with your team in the past month or two where you've sent me some information about where the illegal mining was occurring, and I use that inside of Google Earth, and here is what that looks like. So in Google Earth, I use the Pro version of Google Earth because it has some really nice features, and I'll show you what they are. And this tool is free to download if you haven't used it before. And these pins are what you provided for some of the mining activity. And if you zoom in on any one of these, for instance, this area here, you will see the extent of that mining activity and what happens. I think all of us know the situation, which is a lot of deforestation occurs. After the mining activity is complete, there's left behind this ponding appearance and a lot of contaminated water, and that's what it looks like. So it's this, what we're looking for here would be how can we detect the initial deforestation that the mining activity produces, and how might we be able to identify these mining locations over time. So I use Google Earth, and if you look and see, one of the things you can do with Google Earth is, I'll go back to this site here. Up at the very top, there's a little button at the top here that looks like has a little green arrow on it. This is a time slider. It shows the historical imagery. I really like this feature in Google Earth because it allows me to walk through the time. So what you're looking at, the image that they typically give you, you see down the bottom is 2018. So that's current. If I wanted to go backwards, I use this time slider, and I can go back in time, and there's 2012, and that's all they have for this site. So all they have for this site is a 2015, a 2018, and a 2012, which you see in 2012, much of that mining activity had already happened. If I go down to a different part, and this is all, whatever Google Earth decides to post out there, you get what you get, and it doesn't always give you historical data way back. But I did find in a spot down here, I think it was over here, that there was some mining activity, might have been here, that was visible way back. They had some scenes. There's a scene back in 1986, not very clear. There's 2002. You notice no mining in here. 2015, now you start to see it. And then you keep clicking forward, 2017, and so forth. So you can use Google Earth Pro occasionally to look at some of these older images that Google puts out there. So the unfortunate thing is that they don't always put all of the years. You just get a sprinkling. So in this case, there was a 2015 image. There was a 2002 image. So between 2002 and 2015, we have no idea what happened other than the fact that these mines are all new. So these ponds and this clearing was definitely somewhere between 2002 and 2015. So that's the first thing I wanted to show you was Google Earth Pro. And what I've done in the document was just show you a few examples I pulled out. So in one region in the Ancobra River, on the left is 2002, and on the right is 2011, and you start to see a few areas where some clearing has occurred here. Now let's look, and I go a little further. Same area, 2013, a lot more clearing, and then look at 2017. You have this big horseshoe pattern here and a lot of clearing. So most of the activity in this region occurred between about 2013 and 2017. But we were lucky that Google had these images in these times, because in a few places they only have 2002 and recent. So here's another location. So this is a location I just showed you, 2002 and 2015. These were the only two images they had. There's certainly change occurring between the one on the left and the one on the right, and you can see that obviously. So that's Google Earth. We can use that. Interesting tool, certainly is helpful. The next thing I'd like to do is show you how you can use the Open Data Cube user interface tool to look at a variety of things. We can look at water detection, and I could also do some cloud-free mosaics to see if I can get the same kind of information that I saw there in Google Earth, but I'm going to do it from a water perspective as well. And this is what you're going to get. I've got a few examples here, and I'm going to run this test case for you live to show you how to do it. But this is what the results look like, and you can see the river along here. The river is not water all of the time, and that's probably a combination of the ability of the satellite to detect the water in this narrow river, or it may be dry for certain times of the year. I'm not certain. The other problem is if the water is extremely contaminated and very brown and full of sediment, it often is not seen as water. And I think that's what's happening in some of these cases. So remember this little horseshoe-shaped area. It was right here. This horseshoe-shaped area of mining is what you're seeing here in this water image. And I'm going to show you what this is. This is the percent of time that each pixel has experienced water over a period of time from 2000 to 2017. And what it basically says is areas in red are very infrequent water. So these might just be rain events, but the area in yellow is where the mining activity had occurred, and we can click on it and see. So I'm going to show you some examples. There's one where we zoomed in, and then I'll do two cases, and I'll do something in the North River. This is another example in a northern section, and I'm going to walk through all of this. So let me now jump over to the user interface tool. So this is the UI. I sent you in the email the address for the Ghana user interface. The one I'm using here, just so you know, is a different one. This one's just the one that we use through the Strathmore instance. So don't worry about the address. The one that I sent you in the email is the one you want to go to. So first thing I do is I go to Tools and I go to Water Detection, and then I choose the Ghana data cube. So here we have your data cube, the extent of your data cube for the whole country. And if I zoom into one of those areas that we were looking at, the river, this is the area of the river where you had some problems. There were some problems here, up here, and pretty much all around this region is where your mining activity. So one of the spots we found that worked well is right in this region here, and I know the min and max latitude, so I'm just going to enter it in by hand. But you can certainly draw it on the screen. If I just clicked and went like this, that's the same area. So I'm going to do exactly 5.1, 5.14. I'm entering these in by hand as you see me do this, and 2.2. So that now is the box that I want. And the first thing I'm going to do is just I'll run the entire time series, 1999 to 2016, and hit submit. So what I'm doing here is I am running a water analysis, and you see how fast that ran. That ran just in a matter of 10 seconds. And this water analysis shows the detail of the pixels, the water extent. On the far right, there's a little button over here. Let me click out of that. This button on the far right with the little eyedropper is your legend. That shows you at the top what the water percentage is. So if it's red, 0 to 5% of the time, these pixels experienced water. So if it's black, that means water never existed in these areas over here. But if I zoom into this and I want to find out, well, what is the history of any one of these pixels? There's an eyedropper on the left-hand side up here. It's called Draw Marker. I click on that, and I come down here, and I'll click into this yellow area. And what it's now doing is it's generating a time series plot of that little location there. Now, you can see that location when I hover over it. In the top right of your screen, right here, is the latitude, longitude. So when I click on that spot and I hold my cursor there, you see in the top right is the exact lat-lon of the position of that marker. So it's taking a few seconds here, but what it's doing now is it's going through the entire time series, and it's trying to create a 2D plot of water and non-water. Yes?
Please, can you check your power?
I'm sorry?
The power to your machine.
Is there something wrong with the view? Is anybody else seeing an issue?
Yeah, there was a signal showing that your power is low. So if you can plug in.
Oh, I am. I'm plugged in.
Okay, thank you.
Yeah, it should be fine. I'm not sure why.
Okay, then we're okay. You can continue.
Okay. I'm waiting for this to come up. So in the meantime, while that's coming up, I'm going to go back to the document and show you what the result looks like because I ran it in advance. Here's what it is. So what you get when this runs and you click on an individual pixel. So this pixel right here, I clicked on that, and what pops up on the right-hand side of the screen, and I might just do it again because it might have, I'm going to let it run. Here's what you get on the right-hand side. So for that pixel, you get a plot, two-dimensional, where 0 is non-water and 1 is water. And what you see, and there it is, it just came up over here. What you see is a plot here that any time that the scene did not, for that pixel, did not see water, it registers a 0. If it sees water, it registers a 1. And you notice the jump right here. So sometime in about 2012, or early, maybe late 2012, the very first time is when that pixel saw water. And that is probably associated with the illegal mining activity right there at that spot. So it was non-water up until 2013, and then it became water, and all the scenes after that were water. Down below shows you whether there were clouds or no clouds in the opportunities it had to see this piece of land. What you see on the bottom, these are the number of passes that were no clouds, number of images that had no clouds, and on the top, or I take that back, on the top is clear, on the bottom is cloudy. And what you see is there's a lot of blue on the bottom. That means this is a very cloudy area, and these were the only clear opportunities in a period of 17 years. Not many images because it's cloudy. So this little location was covered with clouds frequently. But you get an idea that you can click around in this user interface at all these locations and find out the timing of when the water came in. Here's another example here where it experienced water early on in 2001, 2003. These might have been flood events like a rainfall, and then later on it experienced water again. Here's another case in the northern part of the river, different latitude, longitude, but you can play with it on your own, and you see it started to show water in that same time period around 2013. but then a couple of these were non-water. It could be, again, because this particular area, the water is so full of sediment that it's not always detected easily. So I just wanted to show you that. I'm going to show you one other thing in the user interface tool that I think is valuable, and that is this ability to create mosaics. So if I wanted to look at this region in Ghana and I just wanted to look at the time history, remember I sort of did this with the Google Earth Engine. Another way you can do this, let's see if I can't zoom in on the proper spot. Where was I? Here it was. If I wanted to create a cloud-free mosaic over this area and see what it looked like back in 2000 and let's say 2, I pick a date range here and I click January 1, 2002, and what you see is it automatically increments at 1 year. So I've chosen my area, I've picked a date range, and now I can pick the kind of map I want to see. I could do a true color. In this case, I'll do a false color, SWIR near infrared green, and I'll do a median pixel mosaic, and I'll hit submit. So what this is doing is it's taking all of the data for 1 year, 2002 to 2003, and it's creating a median pixel mosaic, and it's going to output it on the screen like that. And we'll let that run for a second, and there it was. And I'm going to do that same thing for true color. Let's do that again for true color. And what you will see is along this river right here, that there is no deforestation and no signs of mining activity as early as 2002. When I redo this picture for later years, you're going to see. Now, it's very dark, so it's kind of difficult to see online on here. If you go to the output, you can click on the output and you can download the GeoTIFF or the PNG file. That is sometimes better for viewing. But let me show you what this looks like if I increase it to, say, 2016, and I'll go to 2018. I'll do a 2-year mosaic for the same area. And remember, as you go through here in the 2002 image, there was no changes at all. Let me see if I didn't submit it. There we go. Now I'm running a mosaic. Oh, let's do most recent pixel. We'll let this run, and then I'll come back and we're going to start to do the next step, which is we're going to look at the Jupyter Notebooks, which I think are the most valuable way for you to interact with the data, and I think the most powerful way for you to see. So you can see this is running. It's creating a custom mosaic for 2 years, 2016 through 2017. And these mosaics are not always the prettiest things in the world because they're Landsat 8 or Landsat 7. If I chose Landsat 8, it would probably be quite a bit clearer. And because these ripples that go through here, these are part of the Landsat 7 data. But do you see this feature here? And a lot more degradation along the river here. That is mining activity, and that is mining activity, and we saw that prior. I can do the same thing for Landsat 8. Let me just do a quick one for Landsat 8. So I am doing Landsat 8, 2017, the entire year. I'll do a median pixel mosaic, and I will run this. This should be a clearer image because these bands are only an artifact of the Landsat 7 mission. So there it is. Not a clear image again. I like to take these out and pull them into Photoshop or pull them into QGIS. They look much better than what they do on the screen. But you see a lot of land change here, a lot of land change here. So all along this river, this whole region here is completely different and has been deforested. Okay, so the next thing I want to do is move over to the Jupyter Notebooks. So this is where I think you're going to find the most power in examining these areas, adjusting these algorithms on your own, and doing some investigation on your own. So I've created 2 notebooks that I'm going to demonstrate. If you go to your website and use that password, you will see 2 notebooks. One is called Ghana Mining Tutorial. I'm going to walk through that one today. That one is built on Landsat 7 and has a number of features. The other one that I just recently put together is Landsat 8. The difference being the Landsat 8 data is a little bit cleaner, but remember, it only goes back to the middle of 2013. So if you're trying to get information for anything prior to 2013, you have to use Landsat 7. Here's what we're going to get out of these notebooks. So I'm going to show you some early data, and then we'll jump over to the notebooks and I'll demonstrate. This plot on the left is year 2000 over this region that I was just showing you, exact same region here, this same region that I showed you here. What we have is NDVI, that's a vegetation index plot. You see the area is very highly vegetated and very dark green. There's a little area here of urbanization, and you can see the river. If I use a threshold of NDVI between 0.6 and 0.9, 0.6 and 0.9, I get all these areas in red. And those typically represent dense vegetation like forests. So if you want to do a simple threshold and search for forests, NDVI of 0.6 to 0.9 does a pretty good job. So you see that this goes together with this one on the left very nicely. Now let's see what happens between year 2000 and I run that same exact analysis for 15 years later, and here's what you get. Remember, we saw deforestation along this little horseshoe-shaped pattern, a lot of deforestation along the river. So notice the color change from dark green forest to lighter green background. And in the threshold analysis, it's all picked up. That basically says this area in black has been deforested, this area is deforested, this area is deforested. If I compare the area here of forests, it was 92% forests. 15 years later, it was 79% forests, just in that little plot alone. So let me show you how that works, and then we'll come back and look at the photosynthetic vegetation, PV. So I'm going to jump over to the notebook. Here's one of the Jupyter notebooks that you have. You have this exact same notebook, and you can run it yourself. The one thing I didn't send out to you was from the training, we also have that whole training manual in electronic form. I will send that out to the mailing list because in there you will find a tutorial on how to use Jupyter notebooks. Because I'm going to zip through a number of things here, but it's important that you understand how these things run and how you should use these files. So when you get to your Jupyter notebook, it's going to look like this, your screen. When you go to the original log on here and you log in, you're going to see this. If I want to open any notebook like Ghana Mining Tutorial, I find it on the list. Here it is right here. I click it and it opens up this window. You will see one thing I like to do is from this top, there's this running tab. If I click on running, that shows me all of the notebooks that are open and that are running and that are using computing resources. If you find that someone's running a job and they haven't used it in a while, you should shut these down because all these are taking up computing resources. Even though they might not be running, they're taking up some of the memory. So I tell you this because if you have a lot of people running cases, you want to shut them down. Like if I wanted to just shut down this one here that John was running, I just hit shut down and it disappears. Okay, so I'm going to go back to mining tutorial. So I walk through this, and this is what I did in Nairobi. Told you a little bit about how these are all set up. First thing is it sets up the data cube. It loads in the Ghana data cube and it chooses Landsat 7. It dumps out the extent. And if you see here, the extent of this data is from 2000 through the end of 2017. Here's the latitude and here's the longitude extent. So often we like to plot that. Here it is. It's a big cube. It covers your entire country. But we typically want to do analysis on a much smaller region. So there's two regions I've chosen. These are both in the PDF file. The first one is this region right here. So if I ran 2017 to 2018, that's all I want to run. I'm just going to run a year over this latitude and longitude extent. The first thing I do is I plot out the map. And look at how interesting this is. This is a background image of Google Earth, and you can clearly see the mining activity. It's quite amazing, but it's very clear when you zoom in and you use this inside of our tool. So you can zoom in and see everything down to these water features and where the deforestation occurred. So you see up here on the river, that's an area of urbanization, but this area down here to the south is an area of mining activity. So let's dig into this a little deeper and see how we analyze. So the next thing you do is you load the Landsat data set. You don't have to modify any of this. What I suggest you modify will be these extents right here. So you're going to modify this little field and pick a new latitude, longitude extent, add it in here. And how would you find that? You might search around here on this larger map, and you can use the larger map and zoom in. And let's say you say, oh, I think there's mining activity here. If I click on this map, you can find the lat-lon extremes. Then you put it into this block. Then finally I go down, and I've already run this. Basically what this says is there's 149 pixels wide, 150 pixels in longitude, and there are 8 time steps, or 8 scenes in the year that I chose, which is not a lot of data. It's only 8 scenes. And remember, Landsat can take a maximum of 23 scenes in a year. So not a lot of scenes, and that just means that many of them are very cloudy. So what we do is we'll walk through, you will not change any of this, but this is a cloud masking function. It's basically removing the clouds. And you can just follow the logic if you care to understand Python, but I never touch any of this. I only modify the location of the analysis, and then down here I might modify a few things about the output. So the first thing is, here's an RGB mosaic, which is quite ugly because of this Landsat banding. This is a fractional cover output, which is basically the fraction of bare soil is red, non-photosynthetic vegetation is in blue, which are things like dead trees or brown areas, and then photosynthetic is green. And again, because of the Landsat banding, it's not a pretty scene, but I'll show you what it looks like in an early year because it's much cleaner. And then finally, what I do is I create a plot of NDVI, and you can see NDVI shows these areas of deforestation. And then this threshold plot that we talked about, which doesn't look so good here, but the threshold, you can adjust the threshold. So see my limits here are 0.6 and 0.9. You can change those and rerun it on your own. And then I do the same thing down here for fractional cover. I look at 0.3 to 0.1 for the photosynthetic vegetation. Now, notice something right here. Look how bad the NDVI image is. All the Landsat banding is terrible, and it contaminates the image, and it doesn't look good. If I used a different parameter called fractional cover, look how much nicer it does. So one thing you'll find is that not all of these indices work perfectly all of the time. And so sometimes I may find that my scenes do really well with NDVI, vegetation index. Other times my scenes do well using this fractional cover, because if you look at this fractional cover, it clearly shows the lack of vegetation here and all along the river due to the mining activities. So this was very nice, even considering how contaminated the scene was. This picked it out nicely. So I'll rerun a case for you right now and show you how I would do this. So let's just say I want to go back and I'm going to change, instead of this location, I'm going to go to the north location. So these little pound signs are comments. So if I can add a comment in front of these, it now creates them as comments and they're not noticed. I remove the comments here, and now I have changed from the south to the north, totally different area, 2000 to 2001. In order to rerun this whole thing from top to bottom, what I like to do is kernel, restart, run all, and now it's running. Now what happens when it runs, you will see these little stars. So if you see a star, it means it's trying to execute that block of code. If I run to the top, the first thing it's done, it's already done that because it increments it with a number. So as it is running, it starts to increment these blocks, and you'll see it takes a moment to import the data cube, and then it starts to go fast. The data cube has been imported. It's shown the screen. Here's my new area. There it is, right there. That's the area we're now analyzing. Notice it's incremented, so it's moving right down. It's loaded the Landsat data set. It's done the cloud mask. All these are incremented, so the stars are gone, which means it's running. Here's the mosaic. Still has some cloud issues. Look at that fractional cover. The fractional cover is really clear. Now notice, in this scene, none of the illegal mining or the mining activity is visible because this is 2000, and it's very clean and loaded with vegetation. There's the NDVI, and there is the threshold plot, and it's almost all thick vegetation. And finally, I ran fractional cover. So remember in the last analysis, I showed you a case where the NDVI scene was not very good, but fractional cover had good image. This particular case, fractional cover doesn't pick up much of the water features, but it does a nice job in NDVI. So this is a case where the vegetation index did a better job than the fractional cover index, and these are the kind of things you need to play around with. So before I jump over to the Landsat 8, let me just show you some of the results that I created and I put in the report for you. So in the report, I talk about fractional cover and what it means. And what it does is it iterates the pixel and it says, I have to pick a color for the pixel, and it's going to be some fraction of dark green vegetation, bare soil, or non-photosynthetic. So it ends up giving it a color somewhere in this spectrum. Now look at it, the difference in the left and right. On the left is 2000, on the right is 2017. Big difference, and you can clearly see the changes in the landscape. So using a combination of vegetation index and this fractional cover index, I think you're going to be able to clearly identify the timing of when this all occurs, when this kind of mining activity occurs. So I just did the case here. It was 99% vegetation on the left, 93% on the right. There was a 6% loss in vegetation just comparing these two images. I now looked at the part on the northern river, which is the case I just ran. Here it was here, and instead of using green, I used red. It doesn't really matter, but red indicates forest. Look at the difference between 2000 and now 2017. And again, it's contaminated with the bands of the data, so it's not a great indicator. So the NDVI does not work exceptionally well. But what if I used fractional cover? Fractional cover, here's the left image in 2000 and the right image in 2017. Look how clear the devegetated areas show up, even with the Landsat 7 banding issues. If I compare the left and the right, the difference is 98% vegetation to 75%, a 23% loss in vegetation between these two screens, or these two images. So there's a lot of power here just in the ability to identify where devegetation is occurring. And then the second thing will be, what is the extent of that devegetation in terms of percent area? And so I gave you some examples, and you can see a case here. Fractional cover here didn't show much, but fractional cover for the late year in 2017-18 was completely clear and matched beautifully with that image above, and it does a nice job of picking out that information. So let me go back, and the last thing I want to do is show you a couple other Jupyter Notebooks. This one, Ghana Mining Landsat 8, it's called Ghana Mining L8, is also in your file area, in your Jupyter Notebook area. This one looks at only Landsat 8 data. Now the difference between it is Landsat 8 has a little difference in the way that it does its cloud filtering. So the logic and the code that goes with the Landsat 8 notebook is going to be a little different than Landsat 7. Here's Landsat 8. Again, the extents are 2013 through 2018, early 2018. Eventually, when we make your cube larger, you're going to have all the new data. Same thing, I'm going to zoom in on this area here. Now you're going to notice a big difference between how clean the image is for this one. I ran a 2-year mosaic over this spot, which is 31 scenes. This is the Landsat 8 cloud masking function. It's different than Landsat 7, but it basically does the same thing, removes clouds. Here is a RGB, this is a mosaic that is a median mosaic, and you can see a lot clearer in this image than when you looked at it in Landsat 7, because remember in Landsat 7 had a lot more contamination in these bands that go through the side. Landsat 8 looks pretty clean, but there is some cloud contamination here, and you can see it's impacting the data a bit. Here's what the fractional cover looks like. Very clear. Really nice discrimination here of the bare soil area. So notice, remember this area here was an urbanized city. Urbanized areas show up as bare soil. So a lot of times you can have very cloudy water. So remember, these are those little lakes that are contaminated and full of sediment. They will show up as dark red areas as well as urbanized or bare soil. So there are a lot of things show up in this bare soil red color, but it gives you an idea that some of them are urbanization and some are the mining activity. But in general, there's a big difference between a vegetated forest area and a non-vegetated area. It's very clear. Here is an image for NDVI. And again, I did a threshold plot. Look how nice and clean the threshold plot is. This is that area there. This is only Landsat 8, which is nice and clean. And if I look at that, that was the area that was 79% vegetated. So 2 more quick things before I wrap up. I wanted to show you 2 other notebooks that you don't have yet because we're still working on them and tweaking the details, but I will have them available to you very soon, probably within the next week or 2. And these are done by somebody on our team. John has been working on these quite hard, and what we're looking at is some other things that we can do to identify this mining activity that would increase the power of these Jupyter Notebooks. So you see this image. We've looked at this area before. So what John has done is said, what if I zoom in really closely to a single point? You see that little red dot in the middle of that lake? I want to know the history of that red dot. So what John has done is put together a notebook that plots NDVI and water over time for that point. And notice what has happened here. This particular plot, if it is heavily vegetated and forest, it is typically between 0.6 and 0.9, which is this area right in here. So up until about 2013, that's exactly what this pixel was experiencing. But notice what happened. In 2013, a significant fall in the vegetation index parameter for that pixel. This right here is devegetation. So right here it was devegetated. As it fell down, water, if something is water in a NDVI, it's almost 0. It's like 0 to 0.1 is water, very low. But if the water is contaminated and full of sediment, it probably gets these values of about 0.2 or 0.3 because it starts to look like almost like a dirty soil. Notice the difference. There's no doubt that this was vegetated and then fell off. So we're going to give you this capability to do this analysis, and you can do it on individual single latitude, longitude points anywhere in your country and start to do these plots, which I think are fantastic. The last one I want to show you is phenology. If you're familiar with this idea of phenology, phenology is looking at the vegetation cycles due to seasonality. So if you're studying agriculture and you would like to know the variation in the agriculture throughout the seasons, this is an amazing way to look at it. So what John has done here is he's taken like 10 years of data for a particular spot, and he's binned it in months and weeks of the year and combined Landsat 7 and 8 together. So this is a very powerful plot. And what this is basically saying, for the spot that John chose here, I will bet that this area is a forest. Because the NDVI is around 0.6 to 0.8, this is typical for forests. So if you look at what happened in the spring months, January through May, the average NDVI is a little lower, and then after May, it goes a little bit higher until about November, December, and then starts to fall again. So I would figure, in this particular case, you're getting greening up in the May, June, July timeframe that persists until November. You get drying off in the winter months, and then a green up again in May or June. And I'm not certain of your rainfall patterns, but I would expect you get most of your rainfall perhaps in May and June in this particular location. If John have chosen a different location for this analysis, like in an agriculture plot, what you would see, agriculture is usually between about 0.4 and about 0.8, and it cycles very large. So what you would see are seasonal cycles of peaking in the rainy period and falling off in the period where you're doing the harvesting of the crops. And so this can be very valuable if you were to plot this either binned up over weeks of the year, so you know when is your normal cropping season. But if you just did a long time series of like 10 years, you could see when certain years the agriculture had better response and other years where it was dry and the areas were less able to be vegetated. So just this ability to look at phenology and seasonality variations in vegetation is a very important thing. It could help you with your mining activity, but I think it would be even more valuable for your agriculture activity. So that's all I had for today. So I will stop at this point and entertain any quick questions before we wrap up. Thank you.
Thank you very much, Brian. So, any question from the audience, please?
Hello, Brian.
Yes.
Thank you very much for the tutorials you've taken us through. A quick one, the threshold analysis for the fractional cover.
Yes.
You're able to, for the year 2000, we're able to determine that we had about 98% of vegetation. I wanted to find out if the Jupyter provided that answer for that calculation.
So, got a lot of background. If someone's not talking, can you mute? Yes, Edward, that was you asking the question? You were asking about the fractional cover. Is this what you're talking about? This plot?
Yeah. Yes. So you able to tell us there was a 23% loss of vegetation.
Yes.
And so I wanted to know the calculation, like the Jupyter, will it provide us that answer, or you have to?
Oh, you were wondering where the Jupyter Notebook has that answer?
Yes, like yes.
Yes. So let me show you. It's at the very end. I didn't point that out. So let's go down in the notebook. So you see here, this at the end of the notebook is fractional cover results. And when you go all the way down to where it does the threshold calculation, you see it creates this plot here. Below this spot is where you see the results, right here. This is the threshold count. This tells you the number of pixels inside the threshold and the number out. And right here, that is the percent inside the threshold. So that is 94% vegetation in this image right here. So 94% of the pixels are green and fall within the threshold that I defined, which was 0.6 to 0.9, which is typical for forests. So there's where the number comes out right there, 94%. And if I look at, now that was for NDVI, if I look at fractional cover, it got an answer of 97.7%. So I used two different approaches. One was NDVI and one was fractional cover. They differed by a couple percent. I would always say, you know, that's probably, you know, a typical type error. It's all indices are going to be a bit different. But if you compare NDVI at one time and NDVI at another time, that's what you want to do. Or if you compare the results for fractional cover before and after, I would suggest doing that. Just don't mix NDVI and fractional cover because they're different indices. But you can play around and try different things on your own. For instance, back in up here, if you're a little adept at this, we defined in this block and in this block, we defined NDVI. You could create any index you want in those two blocks. And then what you do is you adjust the code going down the bottom and change out the names. And you can do instead of a threshold plot of NDVI mosaic, you might create an enhanced vegetation index mosaic, EVI, or you might create some other index, you know, Edwards index. So this is where you can modify the notebook yourself. So does that answer your question? I think you were looking for these percentages,
Yes.
right, Edward?
Yes. I was after the percentages.
Excellent.
It answers my question. Thank you.
Surely. Any other questions out there?
Yeah, Brian, the fractional images that you talked about, is it a percentage count of pixels? Is it a count of pixels?
Yes, it counts pixels for those percentages. It's counting pixels. Yes.
All right.
So
and other is, well, I wasn't part of the initial training and other things, but I just wanted to know if you can download the raw image from this site.
right. Yeah. So it basically counts the pixels in here. Now remember that a pixel is typically 30 meters by 30 meters, but that is if you were exactly at the equator. But remember, Ghana's pretty close to the equator, so the shape of your pixels in the latitude longitude projection that we use is only slightly distorted. So if you were wanting to look at an area and calculate the actual loss in vegetation and convert that to area like you know, hectares, you could just use 30 meters per pixel and get a pretty decent representation of the area that was devegetated. Very close, because as you move away from the equator, the pixels get distorted a bit, and they're not exactly 30 meter by 30 meter square. So I tell you that just to be careful that it's not precise, but it's pretty close.
Yeah, hello.
So my second question was, can we download the raw images from the site? Is that possible?
Yes. So are you suggesting like the data that comes out of these analyses, trying to pull off the results here pixel by pixel,
No, what I'm asking is, let's say I want to do some calibration on Landsat 7, so I can do the gap fill. Is it possible to download the raw image from here?
Yes. So let me show you how to do that. That is best done through this, the user interface. So remember, when I was in the user interface, don't pick really large areas, but if you picked smaller areas, and I just wanted to say, all right, I want to do an analysis over this little spot, and for 2017, and I create my medium pixel mosaic, and I hit submit. When you're done creating that mosaic for that location, if I go to the output tab, I click on the output that I just ran. I'm going to go back to my prior one, which was here. It shows you that there were 11 scenes, 9,000 pixels in that scene, 100% clear. Now look what you can do. If you go down here to the output, you can do mosaic geotiff. And if I click download, it will download that geotiff to your local machine. That's a great way to get small geotiff mosaics for further analysis. Now, I'll caution, because on this screen, it looks terrible because we have to use a fairly low resolution for the online image just so that it renders quickly. If you take that geotiff and put it into a QGIS tool or ArcMap or something like that, it looks really nice and it has fantastic clarity. And so that is one way to do it. There's another way to do it, and I'm not sure if you, matter of fact, I know you do have it. I'm going to point you in your notebook. You're going to see your notebook folder, Training Data Export. If you look at the Data Export Python, the Jupyter Notebook, that shows you how you can export larger geotiff files without using the user interface, but using Jupyter Notebooks. And you can put NDVI into your export file. You can do all kinds of things and create a custom export. So there's two places that I'd point you to. Does that help?
Yes.
Hello, Brian.
Yes.
My question, once we are able to know that there's loss of vegetation, in interpreting it, are you able to know whether it is due to deforestation or forest degradation?
Fantastic question. So at this stage, it's difficult to tell without introducing more pieces of information and more indices beyond NDVI or fractional cover. There is a study going on right now as part of the UN Sustainable Development Goal 15.3.1, which is land degradation. And what they have found is that it's fairly easy to detect general deforestation, but if you're just looking at degradation, you have to look at the pattern of NDVI and how it has decreased with time. I'll go back to, and we haven't done that quite yet, but if you were to look at a plot like this one I have on the screen, if I were to see degradation in a forest, you see the huge drop off here is deforestation. But if I were to see degradation and I were to plot this time series over a long period of time for like maybe a small region, this is just one pixel, but if I were to do a small region, what you would see is the general slope of NDVI going downward to the right, which would indicate that the forest is degrading and becoming less green and less vegetated. So the way that it's typically done is by looking at the slope of the degradation over time. And we're going to work that into one of the notebooks, and we'll get that to you soon. I'm looking to see if we have it yet. I know John has done this. There's a plot that John and I were playing around with. Let me see if I can find it really quick for you. It wasn't there. I'll go back and find it, but basically what it is was John was looking at a case where the vegetation was degrading with time, and he plotted the downward trend or upward trend of the vegetation, and that would be synonymous with degradation or improved. So I guess I'm sorry I took so long for that answer. What my short answer would be, at this early stage, we have some tools that can apply to degradation. We'll build some of those into a notebook, and I'll make a point to do that, and we'll let you know when those are ready, and that might be valuable for you to test out.
Thank you very much.
Surely. Any other questions?
Brian, I have a question.
Wait a minute, you're not allowed a question, Syed. Just kidding.
Just some observation from your first notebook. The visual appearance of fractional cover is much better than NDVI. So what is your preference, to take NDVI or to take fractional cover as the first point of analysis and then look for NDVI, or dump NDVI altogether?
I tend to look at both of them, Syed. I have found that with Landsat 7 data and the way it gets contaminated with clouds and the Landsat 7 banding, sometimes NDVI does a decent job, other times fractional cover. I think this is something we're going to have to learn a bit more with time, is how to best utilize these data sets. And that will take some validation data from the ground. So if the Ghana team is able to use some real validation data out in the field, and they know a particular area was recently devegetated, we might be able to look at fractional cover or NDVI and see which one performs a better job of finding the edges of that devegetation. So we're just playing around with some of those things now, and we have a number of land change algorithms that do a decent job, but I tend to think NDVI, as simple as it is, does a really nice job. Any other questions out there?
Fine for now, no. But
Any clarification?
Hello?
Yes, go ahead.
Hello, one more question from Ghana.
Hello, Brian.
Yes.
Yeah, I want to know, with respect to downloading the satellite image, if it's possible to import a shapefile of a boundary of a district, or let's say a region, and then clip it to the satellite before you download it. Is it possible?
So you're suggesting when you say download an image, let me talk about what you might do. I'm guessing that you want to take a period of time, maybe sift out the clouds, create as best a cloud-free image as you can, and then clip that region and then output that as a geotiff. Is that what you're thinking?
Exactly.
That is defined in the, you have this training. So if you go to training data export and you have this notebook, it was part of our training, the data export. At the bottom of the data export, well, at any point here, you pick the data cube you want. Here's where you define your latitude, longitude extents, your time extent. Then later on, it sifts out the clouds. It creates a mosaic. It takes any of these indices that you want to add to your final output file. You may not want to add any of them. Here's how you modify which ones you include in the final file. And then in the very end, here's the code that exports the geotiff and puts it in your folder. And you run this and it puts it in your geotiff folder. So if you go onto your Ghana DataCube site, I think you have a geotiff folder, and this is where the output will be put for the product that you create. So we can help you do this. If you have trouble doing it, let us know. And if you say, I would like to create a GeoTIFF for this block and for this time period, we can show you exactly how to do that in a notebook. Now, I'll ask my AMA team, Syed and others, have we experimented yet with inputting a shape file to clip the boundary, or right now I think we only use square lat lon boxes? Have we used a shape file?
We can use a shape file. Do we want to do it in the DataCube environment, or do we want to do it outside?
Inside.
Probably inside, right? So probably
Inside,
within a notebook, I would think.
Yeah, I think that can be done. What we will do is we'll create a sample notebook to demo that feature, and then that can be used anywhere.
Perfect. We will do that for you and send it your way. So we'll create a notebook that basically references a shape file that you'll have to upload into your notebook folder somewhere. So for instance, let's say if I go to the files, maybe we create a folder here called shapefiles, and you will put your shapefile in the folder, and then when you are running a notebook for data export, it will upload that shapefile and use that to clip the region that you want to create. Now, I will ask you to be careful with the size of the images that you are all creating. Do not create images the full size of Ghana, because they will be massive and take up lots of memory. Make sure that you keep your images reasonable in size, like maybe no bigger than 1 degree by 1 degree lat lon, something like that, just so they're reasonable in size. That's about as big as I would get. So I say that as a warning, because if you start off with these massive analyses and massive regions, they don't typically run very well, and they just take up a lot of memory and they may crash. But that's a good question about shapefile, and I certainly think it's something we want to be able to do. So I have a few notes here, and that is I'll follow up on some of this NDVI change in phonology. I'm going to get you a notebook on that. I'm going to look a little bit more at land degradation and this shapefile, and we'll follow up with you and give you that information. Any other? We'll probably want to go ahead.
Yeah, a quick one. Apart from the exporting it in GeoTIFF in Jupyter, can it also export in NetCDF?
Yes, it can. So in your
at the Jupyter session.
Yes, in your notebook right now, the export we have is exporting to GeoTIFF. We have done it before in NetCDF. Here it is right here, export to NetCDF. So I will upload a notebook for you that is export to NetCDF for Landsat 7 and 8. Okay. And there's just a few minor changes in there. You'll see at the bottom just a few minor changes in what it looks like for the output. It's not much different. Here it is right here. It's quite simple, but I'll upload that.
Okay, Brian. Thank you.
Yep. I always seem to forget that there are people out there that actually like NetCDF.
It's actually nice.
All right, very good. Any other questions, or how? If not,
yeah. Hi.
Okay, go ahead.
I was
Victor.
I just was wondering whether we have questions from some of our partners who linked up in from Senegal. I know one or two persons that join in from Senegal. Is there anyone out there from Senegal? I know we may have the challenge of English, French, you know. Anyone from Sierra Leone?
So who was invited, Victor? Sierra Leone and Senegal are part of this call right now, you believe?
Yes, because I think I saw someone coming from Senegal.
Okay.
We did share the link because we had recently last week had some very wonderful conversations with our partners in Senegal. I was in Senegal. And of course, some of the key institutions expressed direct, immediate, need. Beyond those two institutions that attended the training in Nairobi. So one instance is the Ministry of Agriculture. They have an agency that deals with agricultural policy and agri-data and statistics. And then there's another institution that is called the Center for Ecological Survey. And they were given a mandate to produce every 10 days vegetation cover data for the government. Livestock, pastoralist, type farming is huge in Senegal. It constitutes over 20% of the GDP. So they need to know what the land, the vegetation cover looks like across the months of the year to be able to sustain production. So that institution is required to produce data every 10 days. And they did express that they would like to also harness the power of the data cube. So we've asked them to join in. I think I saw someone joining. The idea is that we just wanted to expose this opportunity to them and then to use it to motivate and in the implementation process for Senegal. And of course, engage further and be able to drive to a point where they can start engaging directly with NASA and that they can have this kind of training also at their country level. IPA, I don't know if you know Dr. Ibrahima Ati at IPA. I think he did say that they've had some conversations with NASA in the time past. Yeah.
Thank you for that, Victor. If you could send me the emails of the points of contact for your Senegal and Sierra Leone group, that would be good because I'll make sure that they get the document that I reviewed today, as well as the Jupyter Notebooks in their folders. Because remember, Senegal and Sierra Leone each have their own dedicated Jupyter Notebook site, and I want to make sure that they know the address and the password for that site, and I'll make sure that the notebook that we went through today is available on that site. I think that would be very useful.
Okay, thank you. I'll do that.
Surely.
Thanks.
Hello, Brian.
Yes.
Yeah, this is Omar.
Yeah, how are you, Omar?
Good. Yeah, Victor, how are you?
I'm good. How you doing?
Yeah, it's good.
Long time.
Yeah. Well, a quick one here. When we had a meeting, the board meeting in New York a couple of weeks ago, we had opportunity of showing the output that Brian and the colleagues worked on around River Ankobra and Tamale Metropolis to the vice president. And he was really impressed about it. And one project that he had been thinking about is digitization of the lands in the country. So what he put forward was we need to arrange a meeting with him, his secretariat, and then the Lands Commission to see how this resource could be used, so that if it is possible that this resource could be used, then maybe there would be some kind of investment to help Ghana train more of our team in the use of this resource to do that kind of digitization. I'm at this point not so much aware of what the details of that program are. So I just wanted to throw it out there to see if it is something that is feasible. Then I would want the team here to liaise with the Lands Commission people and then get details about what that program is exactly about before we arrange the meeting with the VIP. So this is what I'm throwing up.
I'll also add to that. Remember, I did a short analysis on how do you say it? It's Tamale in Ghana. Tamale, and that, looking at urbanization, and it was a fairly difficult process to separate the urbanized area from the background region because of the fact that much of it is very dry land. I have uncovered a couple new indices that the community has been doing research on. I actually saw one of them last week at the IGARS conference. And so I'm going to go back and look at that Tamale analysis that we did and see if some of these new indices do a better job of tracking the urbanized areas. So it's pretty exciting, but I'm glad to hear that you're communicating with people within the government and trying to gain their interest in this, because it's a great resource of data, and we just need some people starting to look at it and utilize it.
Okay, yeah. So I think that is good. So maybe what we will need to do is to get a little more detail about what that project objectives are, and what exactly the project seeks to achieve. And then we'll communicate it through the mails, and then see if it is something that this resource could be useful for.
Sounds great. Any other questions out there?
Yeah, Brian, the last question from my end. The performance of the data cube, Ghana, we had some challenges if so many people try to access it at a go. And I wanted to find out, has it been improved?
Yes, it should be improved. We recently changed the setup regarding the use of the Amazon Web Services. We moved some of your notebooks. We moved the notebook server, and we moved the user interface server to some new, faster instances and cleaned up a few things. It should be running better. I've been running on your server. I tested it out this morning. I ran these notebooks. They ran in about a minute or two on your server. I actually went to your user interface tool, and it ran fine. So try it out. Tell us if you have any issues with it. Again, be careful on the size of the areas. You see, here's the whole country. If you pick an area that big, and start to run analyses, it takes a long time. So try to keep your areas fairly small to do your initial assessments. And remember, I also told you in the Jupyter Notebook, if you go to the running tab, you can track which notebooks are running and taking up memory. So if you get a bunch of people that are running simultaneously, that could cause issues. And what you need to do is shut down processes that are not running. And I've had no problem. So like I said, I've tested out your area. I've been running in it in the last couple days, and it runs just fine.
Okay, right. Thanks.
Sure.
Thank you.
Yeah, let us know. Keep us up to date on your experiences.
Okay.
Okay. I think if nothing else, we'll probably close there today. I have recorded this session, so one way or another, I'll get this out there and available to you as a recording. If anybody else wants to listen and watch what happened today, I have some follow-up with you regarding some other notebooks and some other features that I think would be valuable. In the meantime, I would love for you to go try out the user interface, try out the Jupyter Notebooks, and work with them yourselves. Oh, one thing I didn't mention too is if you go to a Jupyter Notebook that I put up there, like your Ghana mining notebook, what you do is you do File, Make a Copy, and you should make a copy and give it a new name with your name on it, so that if there's only one notebook out there and everyone's using the same one and modifying it, you don't want to mess it up. What you should do is copy it, put your name attached to it, and then you can do anything you want and no one else will touch it. Okay, so I guess that's it.
Okay.
Everyone have a great day, and thank you very much for the opportunity to talk today.
Thank you very much for your time. We appreciate it.
Yep, my pleasure.
Thank you so much, Ryan, and the entire team at NASA. So much great job today. Thanks so much from the GPSDD to your entire team too.
Sure.
And thanks all the guys at Ghana. Great job.
Thank you. Great job.
Thank you so much. I've used your story so much to motivate the team in Senegal and Sierra Leone. Trust me, you guys are the lead in the region. Everyone is looking at what you guys are doing, and it's helping me to keep pushing them because we keep saying, hey, you need to see Ghana's example. It's government leading, and they've shown great commitment, leadership, and we want you to do the same. So your story is really indeed helping to motivate the other partners across, the West African sub-region. Thank you, guys.
Yeah, I also want to thank the Ghana team for taking an interest in this, sending us some use cases, interacting with us. It's very helpful because the things that we are doing with you in investigating some of these applications, whether it be the land change and the mining and the urbanization, these are valuable to many countries across the world that are going to use the data cube. And so if we can learn together, I promise you that it will help you and it will help many more. So thanks for your interest in all of this.
Thank you.
All right. Bye, everybody. Have a great day.
Bye. Well,
thanks a lot.
Bye. Yeah. Bye.
That's great. Members, as we heard from Omar, it's a great project ahead of us, and we will indulge everyone to put in more effort, especially our colleagues who went to Nairobi, because this one is more like a refresher course for us to have been on what we already done. Some of us were seeing stars. So we are here to get a recording. So we have to